hole can't be made in today's wells without drilling fluids. And the guy that normally keeps track of the fluid's condition is the company mud engineer. He usually has a chemistry background because there are so many scientific concepts that go into drilling fluids today. As a roughneck, you never had to deal with the mud too much. You probably never gave it much thought. As a derrick man, you don't get off so easy. Mud is complicated. The things you drill through can really mess it up, and the derrick man is the first person to know about it.
Let's run about.
His responsibility to the driller and the company man is to keep the mud clean and keep everybody informed of any changes he notices. In order to do this, the derrick man has to know a little about mud systems. Well, the best place to start is with the basics. How does the mud get from here to there, and what does it do while it's getting there, and what has to be done to keep it like you want it? So first, let's take a look at what mud does and how it does it. The circulation of the mud, how the cleaning equipment works, and some common sense observations that'll help the driller keep from having a blowout. Then, in part 2, we'll pick up with how your work with the mud relates to the mud engineer and how he controls the mud's properties, as well as the tests that you and the mud engineer will be doing on the mud, what they tell, and how to do them. As you'll see, some of these tests you'll be doing, the others will be done by the mud engineer. Then we'll wrap it up with a little on how to mix the mud, what to wear, and how to keep from getting hurt by some of those more dangerous chemicals. By the time you get through here, you ought to be able to give your driller and mud engineer some real help. We've got a few guys we found that we'd like you to meet before we get started, though. Clint Majors, an independent mud engineer. Dan Acosta, training manager of IMCO. And Charles Braffett of Hughes Tools. These guys know their business, and they'll be dropping in and out to help us explain some of these concepts. Now, mud has quite a few specific purposes in drilling these days. We'll start down at the bottom, at the drill bit. First, as the mud comes out of the bit nozzles, it lubricates and cools the drill bit. Now, you already know about how much weight there is on that bit, as much as 60,000 to 70,000 pounds, and that it turns as fast as 100 RPM sometimes. So it only makes sense that a lot of friction and heat build up. Well, the mud helps carry a lot of this heat off, and it helps to keep the bit lubricated too, as Charlie will tell you.
As the rock bit is on bottom drilling, the fluid that comes out of the jet nozzles also helps to carry the heat away that is generated by the bearings in the rock bit itself and also by the formation. These bearings on some bits are non-sealed, and this mud also acts as a lubricant.
And sometimes special additives will be mixed in to help lubricate. Let's let Clint Majors say a few things on this point.
In normal drilling operations, several problems will arise that will cause us to put different additives into the mud. One of these additives can be oil, diesel, or any compound in this category. These are added to the mud to relieve torque, to help lubricate the hole, and if these problems aren't solved with this, we can go also to a complete all mud. An all mud is an expensive product, and like I said, is only used when the conditions of the hole justify the cost of the product.
So, this feature of the mud makes the bit last longer, reduces drag and sticking of the pipe against the sides of the hole, and means fewer trips for you and fewer incidents of stuck drill pipe for your driller. What this means is that you'll have higher productive drill time and a better penetration rate. The second thing that it does is to direct a jet of fluid slightly ahead of the cutting edge of the bit at the area being drilled to scour the bottom of the hole and keep the cuttings out of the way so that the bit has a good clean area to drill in. If you don't get those cuttings back out of the way fast enough, all the bit's doing is regrinding old cuttings, which means that you're not making as much hole as you could. This scouring feature is called transmitting hydraulic horsepower to the bottom of the hole, and it depends on the properties of the mud and the mud's velocity through the bit nozzles. The third thing that the mud does is to transport those cuttings up the annulus of the hole to the surface, where they can be thrown away. Remember that those cuttings are a lot heavier than the mud, and gravity is trying to pull them back down to the bottom. So the viscosity of the mud and the rate of flow has to be able to overcome gravity and carry the cuttings to the surface. And when the pumps have to be shut down for a connection or a trip, and your velocity can't work for you, gravity's going to be pulling those cuttings right down. So most muds have a feature that turns the mud to a gel when it's not moving. Now this mud has set for a while, so it's had a chance to gel. It pretty much holds this pencil up. Well, it holds the cuttings the same way. When it's being pumped and the mud's in motion, it stays a liquid. That's why it won't hold the pencil now. The time required for the mud to reach maximum gel strength is one of the important factors that has to be controlled real carefully. If it doesn't gel enough, gravity will pull the cuttings back down. If it gels too much at its maximum point, it will take a lot of pump pressure to get it flowing again. And this could force mud back into the formation and damage the hole. So gel properties are the fourth function. Now as the well gets deeper and deeper, the formation pressures increase. And when you hit a formation that has trapped liquid or gas in it, its pressure will force the liquid or gas into the hole. The only way you can control this is with the mud. See, the mud will weigh usually about 12 to 14 pounds per gallon. Now when you stack gallon on top of gallon for 20,000 feet, pretty soon the weight at the bottom gets to be pretty heavy. The idea here is to make it heavy enough to keep the gas, salt, water, or oil in the formation and not let it bubble out into the mud, causing a kick or a blowout. But at the same time you're adding to the weight of the mud, you've got to keep from thickening it too much, or else you get to where it's too hard to pump and you'll start losing your penetration rate. This balance is called maintaining the hydrostatic pressure or the hydrostatic head. So this is the mud's fifth job. Okay, we just said that you want to keep more pressure on the formation, so it only stands to reason that the mud is going to get forced back into the formation, and this is true. It will penetrate the formation, so the mud has to have a quality that will plug up the leaks, and this is the sixth function. Let's face it, if you're losing your mud to the formation, pretty soon you'll run out of mud. Now it depends on how fast it's leaking, but you can see the potential problems, especially when you're not circulating. If you're not constantly replacing the mud, as the level drops, so does your hydrostatic pressure. Eventually, it's going to drop so low that somewhere along the line, up higher, you're going to lose your hydrostatic head, and the gas or oil or whatever you're holding back is going to start flowing. Then, you've got a blowout. So most muds that will be working in these permeable zones will have a quality called filter caking.
One of the major things that we do look at in our drilling fluids is our wall building. And a good drilling fluid should deposit a good filter cake on the wall of the hole to consolidate the formation and retard the passage of fluid from the mud into the formation. This is what we call a wall cake.
So filter cake is that ability of the mud to plug up leaky formations. It works like house shingles. The mud platelets overlap each other until they block the liquid. This helps prevent formation damage. Sometimes, though, when the mud gets contaminated, it changes the shape of the platelets so that they won't lie flat. And when they don't lie flat, they don't seal off. If the liquid continues to penetrate and the solids don't plug up like they're supposed to, the filter cake will get too thick. This can lead to stuck drill pipe once the cake is built up to the point that there's not much clearance between the pipe and the wall. So this is a feature of the mud that has to be controlled. Once it's got the leaks plugged, its next job is to keep the walls of the hole from caving in around the drill pipe. So filter cake is the mud's ability to keep water from penetrating into the formation and damaging the formation. The last thing that the mud has to do is to permit the mud engineer to get information about the formations that are being drilled. So, the characteristics of the mud have to provide an environment that doesn't interfere with tests that are performed on what is brought back up, make for easy retrieval of cores and cuttings, and even have properties that allow electric logs. Well, you take all of this into consideration, and you can see there's a lot more than just mixing clay and water. There's a real science to it, and hopefully we can help take some of the mystery out of it for you. So once more, the basic features that we've got to have out of the mud. To lubricate and cool the bit. And you'll learn that in some cases oil is used to help do this. To keep the bottom of the hole clean of cuttings by transmitting hydraulic horsepower to the hole. To carry cuttings to the surface. The ability to hold cuttings during periods of no circulation, gel strength. To provide a hydrostatic head. This is controlled by mud weight, one of your measurements. To build filter cake to protect the formation from damage and limit water loss. The ability to form a filter cake is important, and so is thickness of the filter cake. So there are tests to figure this out. And finally, to provide information about the hole. A bunch of tests are made to figure all of these things out, and your cooperation with the mud engineer and the driller is important. Neither one has an easy job, and the mud conditions affect their jobs and success. As we go over the mud in this series, you'll start to understand these things a little better, and you'll come to see what the mud engineer uses to control these conditions. But for right now, we want to go over what happens from the top side, how you keep the mud clean. We'll start off with how the mud flows in its normal route through the circulatory system. It's drawn out of the suction pipe and fed into the mud pumps. The mud pump sucks mud in, then forces it out through a pulsation dampener to even out the flow. The pulsation dampener isn't anything very fancy, just a pressurized globe with a bladder in it that evens out the erratic pulses of the mud pump piston as it goes from the suction to the push mode. Then the mud travels up to the top of the derrick, where it hooks into a flexible hose called a rotary hose that connects to the swivel. It goes down through the Kelly, which screws into the drill pipe. At the bottom of the drill pipe, the mud is forced out of the nozzles in the bit. After it's picked up the cuttings, it rises up the side of the hole. When it gets to the top, it goes through the annulus and a series of pipes that lead it back to the mud pits, where it's cleaned by a series of special pieces of cleaning gear. The first is the shale shaker. All it is a vibrating screen that separates out the larger cuttings. The mud falls through a screen and into a settling pit. The cuttings shake off. Then the mud travels to a series of cyclonic or centrifugal type separators that force some of the smaller particles out. The way this thing works is by centrifugal force. The mud enters the separator at the top and is spun around. The lighter mud swirls up to the top and out. The heavier cuttings, silt, or sand fall to the bottom and are thrown out. From here it goes into another series of settling pits that allow the really fine sediment to settle out, and then travels to the suction pit, where it starts through the system again. There are a couple of other pieces of specialty gear that do things like remove gas and smaller sediment from the mud, but these are our basic pieces of gear. Now let's take a closer look at this cleaning equipment so that you'll know what to be on the lookout for and how to make these things work. Again, the first piece of cleaning gear is the shale shaker. It's a fairly easy piece of gear to operate. You just turn it on and adjust the flow gates to let as much fluid through as you can without losing any over the end. When you first start it, you might have a sort of capillary action with the mud as it flows over the screen. One thing that'll cause capillary action is dirty screens. Always keep them clean. Now be sure to keep an eye on the type of cuttings that are coming across that shaker screen. Most of them will be smaller chips like this. If you see the size change much, be sure to tell the driller. He needs to know. That'll tell him he's drilling through another type of formation. It may or may not mean trouble to him. If the size increases a lot, get word to him as soon as you can, especially if you see larger chips come across. This means he's drilled into a section of formation that's soft. When you see this, you can bet that the walls are starting to slough off and he's about to get stuck. You might also look at your reserve pit levels to see if you're losing fluid. If you've got both of these problems, you've got real problems. Get on that phone to the driller now.
Hey, driller! You better shut it down and circulate. We got some boulders coming across that shaker.
Also, be watching for clabbering. There's a little bit of clabbering here. It looks just like clabbered milk. It means that your mud has been contaminated. Tell your driller and your mud engineer immediately. Okay, now we've got the mud over the shaker. It'll go through a settling pit next. Some of the particles will settle out here. Then it's drawn off and sent through that series of centrifugal separators. The first one is the largest one, called a desander. Let's take a close look. It has a cone that's made out of neoprene or a plastic rubber of some sort, depending on the manufacturer. On the desander, the cone will be housed in a metal shell with a weep hole. The cone will wear out, and when it does, you'll see mud spurting out of this weep hole. Then you need to replace it. And if your sediment isn't coming out in a spray like this, you've got a problem. Try adjusting the flow level. It could be that too much liquid is being forced through the separator. When you've got a rope pattern like this, you're losing too much of your mud. All of the cones ought to react about the same. If only one has a problem, you've probably got something stuck inside the cone of that unit. It's either something that should have been removed by the shale shaker, or maybe your pit watcher accidentally dropped his pencil or something into the settling pit, and this is where it got stuck. Anyway, you'll need to take it apart and clean it out. Remember, your discharge should look like this. The smaller of the separators is called a desilter. The orifice is about 3/4 of an inch. It does the same thing as the desander, but it removes smaller particles. There's really not any difference in the way that the two work. Once the mud clears the desander and desilters, some rigs will have a centrifuge. The centrifuge separates the mud weighing material, which is usually barite, from the mud. It is a high-speed, mechanically rotated system that uses centrifugal force to separate the solids. Then the mud might go through a degasser that removes the small bubbles of gas. There's really no adjustment to make on it except to turn it off and on and pipe your mud through it. From there, the mud goes through a series of settling pits. All of our rigs are different in the way they're laid out, but it's pretty standard that you'll have 2 or 3 settling pits and a reserve and suction pit with agitators to keep the mud's weighting material stirred up. From here, the mud goes back through the mud pump and back down the hole again.